Multi-biometric systems utilize information from multiple biometric sources to establish an identity. Based on the information sources used, multi-biometric systems can be classified into multi-sensor, multi-algorithm, multi-instance, multi-sample, and multimodal systems. In the first four scenarios, a single biometric trait provides multiple sources of evidence, but in the fifth scenario, different biometric traits are used as sources of evidence. As you can see in this figure, multiple biometric sources can be achieved from different parts, multiple instances, multiple representations, multiple sensors, multiple samples, or multiple biometric traits. In all of these four, we use the same biometric traits and get different samples or instance or different sensors. But here in multiple biometric traits, we use two or more than two different biometric traits to capture the biometric information of the person. For example, here we use both of the face and iris. But in this one, we use two different sensors to capture different information from the fingerprint. Or in multiple instance, for example, here we use both eyes iris pattern, both left and right eyes, and here in multiple sample we use the fingerprint. We ask the user to give us multiple sample of his or her biometric traits, and these different samples are used as the multiple biometric sources. Then we should evaluate the performance requirement and the cost constraints in order to design a multi-biometric system. After you select your biometric sources and acquisition sequence, we should decide about the fusion level and fusion methodology. In a multi-sensor system, a single biometric trait is captured using multiple sensors in order to extract diverse information. For example, a system may capture two-dimensional texture content of a person's face using a simple CCD camera, and also captured a three-dimensional surface shape by using a range sensor in order to perform authentication. This is a multi-sensor system with simple CCD camera. We capture this type of image. With range sensor, we can capture a 3D model of the face and use both of these two evidence as the source of your biometric information. Or here we have two different type of fingerprint sensors. Each one capture different type of information from a finger. In multiple representations or multi-algorithm systems, the same biometric data is processed using multiple algorithms. For example, a texture-based algorithm and an minutia-based algorithm can operate on the same fingerprint image in order to extract diverse feature sets that can improve the performance of the system. In this figure, you can see the minutia feature extracted from a fingerprint, and in the right side you can see the texture features extracted from the same fingerprint. In a multi-instance system, multiple instances of the same body trait will be used. For example, the left and right index finger or the left and right irises of one individual may be captured to verify an individual's identity. Offer his forefingers of the left hand, both thumbs and forefingers of the right hand to the sensor, and all of these samples and instances will be used to verify the person identity. In multi-sample systems, a single sensor may be used to acquire multiple samples of the same biometric trait in order to account for the variations that can occur in the trait, or in order to obtain a more complete representation of the underlying trait. For example, a fingerprint system equipped with a sensor with a small sensing area may acquire multiple dab prints of an individual fingers in order to capture various regions of the fingerprint. These fingerprint images can be fused together to form a complete fingerprint, which will provide a large number of minutiae. So as you can see, since the sensor is very small, only a small area of the finger can be captured each time. We have two samples A and B, and then we combine them and fuse them together, and by some image processing techniques we can find the overlap point of these two fingerprints and construct a whole fingerprint, then give it to the minutia feature, extract some minutia features from this whole image and give it to the next part of the system. Multimodal systems combine the evidence presented by different body traits for establishing identity. For example, in some early systems, they used both face and voice features to establish the identity of an individual. Or here, have a phone which captures both the fingerprint and a digital camera capture the face image. Also, the microphone can capture the voice, and all of these three biometric traits can be used to identify the person. Or in this image, a whole hand scanner is used, so it can simultaneously acquire palm print, fingerprint, and the hand geometry or hand shape a person, and use all of this information or all of these biometric traits to establish the identity.